How's it going, everybody? In this video, we're going to continue our hierarchical VPLS or H-VPLS rollout. And this time we're going to be talking about dealing with the BGP auto discovery and an E-LAN design, where we're going to take what we did in the previous video with the manual pseudo-wire configuration, and instead of using pseudo-wire configuration to determine who we're going to peer with inside of the NPE core, we're going to flip over to BGP auto discovery. We're going to go E-LAN, so we're not going to be super specific on which devices are actually going to be adding in pseudo-wires, or who's going to be able to communicate with who. We'll determine that in an upcoming video where we talk about E-tree. But for right now, this is basically where we're trying to go with the deployment. So let's go ahead and talk about the actual rollout again, just so everybody's on the same page. So from an operations perspective, we will have the NPEs here in the core, and we will set up connections between them, like so. We have NPE 1, 2, and 3, and then we will have UPEs 1, 2, 3, and 4. So 1, 2, 3, and 4, and then they will form connections to their respective NPEs. Right now we currently have service instance 500 allocated. We're going to add service instance 501 on all the CE devices. So this will also be our VPN ID for the VFIs on the NPE side, and our bridge domain ID as well. So the cool thing about this config is that since we will have it rolled out this way, it'll make it very easy for us to go in and configure everything that we need to. We won't have to spend as much time on the NPE side configuring NPE to NPE communication, because all of that will be configured or spun up automatically through BGP auto discovery. So we will need to go through and make sure everything is squared away with those guys so they'll be able to communicate. So we'll have to add to CSR2 and to XR18. We'll add in 8, 4, and 6 in towards the end of the video, or at some point in the video when we're configuring that. We'll get all that stuff squared away, and then we'll have underneath the bridge domains facing the UPEs. So for example, on CSRA pointing towards CSR1, we'll have to create a pseudo-wire that points down to the UPE. So the NPE pseudo-wires we won't create, okay? They'll be automatically spun up for us, where we go to the UPE to NPE communication. So NPE 1 to UPE 1 up here, that will be a manually defined X connect. We're going to define that underneath the bridge domain that points towards CSR1, and we're going to create an L2VPN X connect on CSR1 that points back to the associated NPE, and go from there. So with that understanding laid out, we're going to go ahead and get everything started and configured and all that good stuff to go. So I'm going to go ahead and we're going to start on 4, 6, and 8. So we're going to start on CSR4. So we're going to go ahead and log in and get this guy up and running. First thing we're going to do is we're going to create a pseudo wire. So interface pseudo wire, and I'm going to call this 501, and then we're going to call this 11. So that's going to be NPE1 to UPE1. And then we're going to encapsulation is MPLS, and then the neighbor is going to be 10.0.0. I'm sorry, this is 4. I need to go to 8 for this to work. So we go up here, we'll type in interface pseudo wire is going to be 501.11, and then encapsulation MPLS. Neighbor is going to be 10.0.0.1, 501.11. We're going to exit out of there, and then we're going to go to the VFI config. So L2VPN, I'm sorry, VFI context, and here we're going to call this 501. We're going to type in VPN ID of 501, and then we're going to specify that its auto discovery is BGP, and the signaling, we can specify whatever we want. So in this case here, I'm going to do LDP. I'll specify LDP, and I'll hit the enter key, and I will allow the we'll keep the auto route target going so that it's E-LAN, so everybody will be able to talk to everybody else. Then I need to come in underneath here and type in bridge-domain 501. I'll type in member of VFI, and it's going to be 501. And we'll type in member pseudowire is going to be 50111. And there we have it. So that's pretty much all we need to really worry about. So what I'm also going to do is on CSR8, I'm going to router BGP 1, no BGP default IPv4, and I type in neighbor of 10.0.0.2, remote AS of 1. The update source is going to be loopback 0, and then the address family L2VPN VPLS. We're going to go ahead and activate this adjacency, or I should say this peering, and get that all squared away from there. Now that we have that going for us, we can go in and pretty much mimic this config for BGP. And I'm also going to do neighbor of 10.0.0.18, remote AS of 1. Specify the update source of loopback 0, and then underneath the address family L2VPN VPLS, we'll go ahead and activate it. And then we're also going to do a prefix length size of 2, because we definitely need that. So we're going to take do show run section BGP. I'll maintain this config right here, and I will just dump it onto CSR6 config T, copy and paste, and then CSR4. Go ahead and just dump that in there, like so. Now that we have the BGP config on the NPE routers, then I can go ahead and go back to CSR6, and we can go ahead and get the interface pseudowire. In this case here, it's going to be 501, and I'll type in 34. So it's going to be NPE 3 down to UPE 4, so 34. I'll type in encapsulation MPLS, and neighbor is going to be 10.0.0.7, and a VCID of 50134, like so. Exit out, and then it's going to be L2VPI, and then context, and this guy is going to be 501. The member is going, the VPN ID is going to be 501, and then underneath here, we're going to type in auto discovery BGP signaling is going to be LDP, and we're going to leave auto route target on. Then we need to create the bridge-domain 501, and then underneath here we need to type in member of VFI 501 and member of pseudowire 50134, and then go ahead and exit out of there. Now that we have that in play, we can go back to CSR4 and get him squared away. So we'll type interface pseudowire. In this case here, we're going to have 501.23. 501.23, no dots. Encapsulation MPLS, neighbor of 10.0.0.5 with a pseudowire of 501.23. And then exit out of there. And then we're going to create the L2VPN VFI context of 501, VPN ID 501, and then member of pseudowire 50134. 23. No, I'm sorry. No, not that. That goes underneath the bridge domain. Auto discovery BGP LDP or signaling is going to be LDP. Exit out of there, and then bridge-domain of 501, member VFI 501, member of pseudowire 501.23. Exit out of there. Now we actually have to go back to 8 and configure him with one more setup. So let's go ahead and exit out of here. Interface pseudowire 501.12, encapsulation MPLS, neighbor of 10.0.0.3, 501.12, exit out, and then L2VPN VFI context is going to be 501, and then we're going to specify a VPN ID of 501. From there, it's the auto discovery BGP signaling is LDP, and then we create bridge-domain 501, and it's going to be member pseudowire 501.12, and get that squared away. So now that we have all that done, the next thing for us to go do is a CSR2, and we're going to go to global config, do show run section BGP, and we should have a little bit of config here. So we have all of the UPEs defined. So technically we don't need the UPEs defined anymore, but I'm going to add in the NPEs in the core just so that we have something to reference them by, so that BGP auto discovery will work the way that it's supposed to. Because you might have scenarios in a real world environment where you have both a PE to PE home run pseudowire, and you might also have scenarios where you have customers that are doing H-VPLS. You could have a mixed bag. So what I'm going to go do is a router BGP1 neighbor of 10.0.0.4, and peer group is going to be IBGP, I believe is what I gave it. Yeah, it is. We'll do 6 and 8 respectively. Address family L2VPN VPLS, and then we're just going to kind of come in here and do a 4 activate, 6, and then 4 respectively, and that'll activate those adjacencies and get them all squared away. And then we're going to do the same thing on 18. So we'll go underneath here, Rob and Cisco, show run router BGP, and we're just going to basically take these lines of config here, go to global config, router BGP1, neighbor of 10.0.0.4, copy paste. Same thing with 6, and then 8. And commit that. I'm sorry, I need to go to, let's do signaling BGP disable. And let's go to, let's do a show config, and we'll go to 6. I believe did I already fix 6? I fixed 8. 8's, I gotta fix 6 now. And I will come to this guy. I'll come in here and BGP disable, and then I'll do the same thing for 4. And do something like this. And BGP disable. We will flip on BGP signaling in an upcoming video, because I'm playing around obviously with a lot of different variations here. So just to show you what the different capabilities are like, and that's what we're going to go take a look at. But for right now, LDP signaling and E-LAN. So we have that show config just to verify that those things have taken effect. BGP disable, BGP disable, BGP disable, and commit. We're going to go to root. And then we're going to go over towards, now that we have the configuration in the core setup, now we need to go to the CSR1, for example, here, and go to global config. We'll type in interface pseudowire, in this case here's going to be 501.11, encapsulation MPLS, neighbor is going to be 10.0.0.8, and the pseudowire ID is going to be 501.11, exit out. And then it'll be underneath the interface gig 3, it'll be service instance 501 Ethernet, encapsulation.1Q 501. And then we're going to go underneath the L2 VPN XConnect context of 501. And then we're going to specify a member of gig 3 service instance 501 Ethernet, or I'm sorry, it's 501. And then member pseudowire of 501.11, and then with that should form the connection and get the connectivity up and running to 8. And what should end up happening is we won't get any learned information on bridge domain 501 on 8 right away, and that's because the attachment circuit on router 1 side is not set up yet. So if we were to go to 8 and do we show bridge domain of 501, we're not going to see any connections coming in right now. Now if I go back to R1, just to give you some, to help you understand how this works, go to global config and interface gig 0/0.501 encapsulation.1q 501, and then IP address of 10.51.51.1/24, and do that. We go back to 8 and hit the up arrow. We should be learning a MAC address in, and we are, and that's the whole point here. We are receiving information in when we go to set this up. So we can this process is repeatable. It's just a lot of repetitive configuration. So, but it's, for me, it's good to keep doing it. It's good for you guys to see all the individual pieces, because if you overlook one little portion of it, or you're like, oh, I configured the bridge domains, but you didn't configure the pseudo wire from the NPE down to the UPE, but you did the service instance config on the attachment circuit, you did the interface pseudo wire pointing back towards the NPE on the UPE, but you didn't tie it to the L2VPN X-Connect. Guess what? Nothing's gonna help you. So we're gonna go back to CSR2 now, or sorry, CSR3, and we're gonna go ahead and get him squared away. So on here, we'll type an interface. Well, let's not configure the pseudo wire first. We're gonna type an interface gig 6 service instance 501 Ethernet encapsulation.1q 501, and then we're going to go to L2VPN, X-Connect context of 501. Member of pseudo wire, member is going to be 10.0.0.8 on 501, and then the VCID here is going to be 501.12, and then it's going to be encapsulation MPLS, and then we can do member of service gig 6 service instance 501, and we can go ahead and exit out, and that should bring that connection up. Now since that's going in, I'm going to go to router 3 here, and I'm going to go to interface gig 2.501 encapsulation.1q 501, IP address of 10.5151.3/24. And then if I go up to CSR8 and I hit the up arrow, we should be learning a secondary MAC address, which we are. So everything's working the way that I would expect it to. Now I could keep the MAC address learning propagation happening continuously if I was to turn a dynamic routing protocol on that would send a hello every so many seconds or something like that. That's definitely an option here. So for right now, I'm not doing that, and it's already taken me about 2 to 3 minutes to configure each node. So this probably will take a total of half an hour roughly to set up. So for those of you that are studying for the CCIE Service Provider Lab exam, it's important to make sure you're able to pick apart what it is that they're asking you. They're probably going to be pretty specific, but if you're inkling that they might be referring to H-VPLS and not regular VPLS, you would want to make sure that you understand the core differences between those. So now we're going to go to CSR 5 and do the same thing. I'm going to go to config T and then interface gig 3 and then service instance 501 Ethernet encapsulation.1q 501, and then L2VP or X-Connect context is going to be 501, and then member of 10.0.0.4, and the pseudo wire ID is going to be 501.23. Of course, encapsulation MPLS. There was also another question: can you add a template here? And you can templatize the communication between the UPE and the NPE all day long, just as you can templatize the config NPE to NPE. You just have to tie the template to you would be tying that to the bridge domain. No, the VFI, because the VFI is the one that's actually building the pseudo wires. So you want to make sure you do that. But yes, you can do that. And then we're going to type in member of gig 3 service instance 501, and that should spin up now too. And then we're going to go down to router 4, interface gig 0/0.501, encapsulation .1q 501, IP address of 10.51.51.4/24, and then go up to CSR4 and show bridge and domain 501, and we are learning MAC addresses in, which is awesome. So that's how we would do that. And then last but certainly not least, let's go over to CSR7 and get him squared away. So interface pseudowire 501.34, encapsulation MPLS, neighbor is going to be 10.0.0.6 on 501.34, and then it's going to be interface gig 3 service instance 501 Ethernet, encapsulation .1q 501, L2 Xconnect context and 501, member gig 3 service instance 501, member pseudowire 501.34, correct? Yeah, 501.34, and go ahead and exit out of that, and that should come up Ricky Tick, router 5. Whoops, oh, okay, let me pause. So what I'm going to do now, while I wait for this guy to do his thing, I'm going to go to the other routers, R1, R3, R4, and I'm going to turn EIGRP on, just so that we can keep the configuration working the way that we need it to. So we're going to go to router 1, router EIGRP 501, and then network of 10.51.51.0/24. Do show run section EIGRP, and we will grab that config out just like this. Go to router 3. That should form an adjacency, and it does. We should go to router 4. That should form an adjacency. Well, once I hit the enter key. There it goes, and then router 5. We'll go to interface gig 0/0.501, encapsulation .1q 501, IP address of 10.51.51.5/24, and just like that, and we should get adjacencies with 1, 3, and 4, which is exactly what I was looking for. Now, the cool thing about this is, now that we have everything up and running, now we will never, our bridge domains will never time out, because the EIGRP hello is every 5 seconds. So now if I go to CSR8, for example, and I hit the up arrow, I'm going to see 4 MACs. And you'll notice that the MAC address, the age on the MAC addresses never goes below 296. And the reason why is because the EIGRP hello is every 5 seconds. So at worst, we're going to lose a neighbor in 15 seconds, which is 3 intervals, which is how often EIGRP sends a hello. So that's basically your BGP auto discovery. So let's actually look at CSR8 and do a show BGP L2VPN VPLS all and do a summary. And I've got connections to router CSR2 and CSR8 or XR18. If I come in here, I can see the connections coming through. Why do I not have anything coming in from CSR2? Let me double check my config here. Section BGP. 4, 6, and 8. Oh, I've got LDP. Oh, that's why. I suppressed the signaling of LDP. That's why. So yeah, that's going to be a problem right now because I'm not trying to do. Right now, I have BGP auto discovery for a PE to PE UPE configuration, home run. So CSR1 to CSR7, for example, and that's BGP signaled. Where here we're not doing that. I should be able to overwrite this. So if I was to go back to router BGP1 and then address family L2VPN VPLS and type in neighbor of 10.0.0.4 and suppress signaling protocol, and then LDP, and type in no neighbor, do show run section BGP. I'm curious to see what that would take. It will not, because the route reflector client's been associated, so I'd actually have to disconnect this configuration, because this these two iBGP peer groups are associated to all the neighbors. So if I was to come in here and do no and pull this command out, and that's going to reset all the connections. And if I was to type in route reflector client, right? So that's actually going to break a lot of things. So just give that let's give that a minute to settle down. If I was to, so let's do undebug all, because I don't need to see all of that information. So that'll take a couple seconds for that to filter out. All right, it's been going for a couple of minutes. What I'll do is a neighbor of 10.0.0.1. I'll come in here and type in suppress. I'll activate it. And then I will also come in here and do a suppress signaling protocol LDP for 1. I'll do the same thing for 3 and 5. I should, whoops, I meant to do this for 3, because we're doing BGP signaling towards the PEs on the outside. So what I'll do is I'll come in, activate on 5, and then I'll come in and I'll do this for 5. And then I'll do a 7 will be an activate, and then 7 will activate here. So do show run section BGP. What you'll see is this. Now I have the other 4 should be working fine. So if I go to 4 now, and let's do it, or maybe it was 8 that I was supposed to look at. So I need to suppress signaling protocol. We're doing LDP signaling, so I need to go back to 2, and these guys are running, but you'll see that we're suppressing signaling protocol LDP. So if I do show BGP L2VPN VPLS all summary, and I come in here and I do this, do I not have it set up right? Because I'm not receiving any prefixes at all. No, everything looks pretty kosher. Okay, so let me just double check some things. CSR1, show run section BGP, suppress signaling protocol LDP. So we're doing BGP signaling here. So on 4, show run section bridge, or I should say L2VPN VFI, we're going to have 2 of them here. We're going to have 500. I'm sorry, in this case here it's LDP signaling. So for those guys, we don't want to suppress LDP. Where on 2, do show run section BGP, we are suppressing LDP on 1, 3, 5, and 7, but not 6. Actually, you know what? I need to turn these into route reflectors too. So, because right now they're not. So what I'll do, and this is where this config gets a little long in the tooth, because now you have to, if you're going to do a mix and match, which is what we're doing, we have to turn off, make these route reflector clients. So what I'll do is I'll type in neighbor of 10.0.0.1 route reflector client. And see, it's going to give me a hard time because these are peer grouped. And this is the only drawback to that. Actually, let me try doing this. Let's do a template peer policy of iBGP route reflector client, address family L2VPN VPLS, and then neighbor of 10.0.0.1 inherit peer policy iBGP, inherits peer group, cannot inherit template. Okay. So what I'll do in this case here It's a sticky wicket here because I can't, because of the way that I got this configured. I would have to do, I could reconfigure it, but, so let me go do that real quickly instead of walking you, let me walk you through one example, just so you understand where I'm coming from. So to help you understand why we would have to do what we have to do. So what I'll do is I will come in here and I will say no neighbor IBGP peer group, right? So that'll take down all the adjacencies, right? Or I should say all the peerings. Then we'll type in template peer session is going to be IBGP. And if this may or may not work, I'm going to test it out real quick. We'll type in remote AS of 1 update dash sources loopback 0 exit out, and then neighbor of 10.0.0.1 inherit peer session IBGP, and then address family L2VPN VPLS. We're gonna associate and here inherit peer policy IBGP, and then we'll activate the adjacency first, and then apply that. So the neighbor comes up, and if we do show run section BGP, underneath the peer policy, we are simply route reflector client. So this is where, assuming that it'll scale the way that I want it to, let me go and do the same thing for 7. So let me go ahead and exit out here for 7. Let me do peer session, we'll do 7, and then address family L2VPN, neighbor of 10.0.0.7 activate, and then peer policy for 7. That should come up. There it goes. So now if I do show BGP L2VPN VPLS all, if I do a summary, I should be learning stuff in. And I'm not. It might be a preference-based thing. Show BGP L2VPN VPLS all summary. I have a peering. Okay, well I definitely have broken the 1000 service instance. I definitely broke that. There's no doubt about that. So that's not working. But the point that I was trying to make, or was trying to test out, was you won't be able to, when you get very large configs, it's going to be one or the other. You're not going to, you shouldn't be going and mixing and matching. That just wouldn't make sense. Unless you're on XR, it appears to work for XR just fine. But in a real world deployment, you wouldn't be using a CSR or an ASR 1000 or an ASR 1000 series router mixing and matching. You would do one signaling method or the other. Now, I can probably go back here and get rid of the peer policy. So do show run section BGP, because right now we're missing a lot of stuff. So let me just go ahead and do this. Let me pull these guys out. Let me reconfigure this real quickly. I'll pause the video. I'll reconfigure it, because what should end up happening is as the LDP signaling comes on board, we shouldn't have to deal with any mismatch of configuration. So I'm going to give that a shot. Worst case scenario, I just roll the config back. Not that big of a deal. Alright, I did a little bit of testing, and as you can see, things are starting to work again. If I go back over here to CSR1, I hit the up arrow. We are learning stuff in. If I look at this, now we can see stuff coming through again. So if I was to continue to work with this, we'd see stuff coming across. And that's what I would expect to see. So let's go ahead and let me show you what I'm doing on CSR2, who is a route reflector. So do show run section BGP. The config does get very, very long and repetitive. So let me go show you what I'm basically doing. I've got 4, 6, and 8. So if I go to CSR4 and I show BGP L2VPN VPLS all summary, I am learning connections in for 501, which is what I expect to see. and I have that coming in and working. Now if I go back to CSR1 and I do this, I can see for 501 or 1010, which is LDP signaling. If I continue to do the process for the rest of the routers, I will continue to do that. So I'll type in neighbor 10.0.0.3 remote AS of 1 update source loopback 0. Let me just do the same thing for 5 because I'm right here. And then address family L2VPN will activate 5, will activate 3. We'll go to here to have a route reflector client for 3 as well. And then that'll come up, and then for those specific peers, I'll come in and type in suppress signaling protocol LDP, and for 5 it'll be suppress signaling protocol LDP. Now with that in play, do show BGP L2VPN VPLS all summary. I should be learning stuff in, and now I should have connectivity to all those sites for 1010. If I go back to CSR1, hit the up arrow, for 1010 I have all those connections coming through that I need to, which is what I would expect to see. So that's working as it's expected to, because this is BGP signaling right here. So we did have, when we configured LDP signaling, that was this guy, right? So I could play around with it, but it's one or the other. Since I converted it from 1000 to 1010, it changed the operation. So if you're not familiar with what I'm referring to, go check out the video on VPLS, BGP auto discovery with when I did BGP signaling, and you'll see what I'm talking about. So there's that. Now that I have that in play, I can go to CSR4, and I'm still learning all my connections this way. If I go to CSR2, I can see that I have my connections in here in the core. You'll notice right here, these guys are LDP signal. That's why you don't see any VEID here, which is why you have that on up and running. So if I was just to come up here and do a summary, I should expect to see prefixes being learned in, which I do. And of course, do show run section BGP. This is a lengthy config, but I'm being selective as to who's doing the signaling and who's not. But I've got connections going to everybody, 1, 3, 4, 5, 6, 7, 8, etc. So as you can see, it does get lengthy. Just imagine if you had thousands of these devices. It would just become almost unmanageable to maintain this level of config. And then if you accidentally went underneath the wrong neighbor and enabled the wrong signaling mechanism, maybe you turned LDP off when you meant to turn BGP off by accident, I could see this being a problem. But knowing how to provide separation based off of the mechanism, that's important. So that's basically what I meant to show you guys. So let's go back to router 1 and make sure that we can still ping. So show IP EIGRP neighbors, and I still have my connectivity up and running to 3, 4, and 5. So if I was to ping 10.51.51.3, 4, and 5, I can ping them all. I go to CSR4, show bridge dash domain 501. There we go, and we're in good shape. That is the configuration that we want to look at. This is BGP auto discovery with LDP signaling inside of the NPE core. Now we are going to do, in the next video is going to be with BGP signaling, but we're going to reconfigure it for 502 and continue to go forward with that so that we can have as many variations as we can as we're going along with this. So pretty straightforward for the most part, as you guys can see. And then we're going to continue this process until we've covered as many variations as I can think of to play with. So until next time, guys, thanks so much for stopping by, and we'll catch you guys in the next video.